Welcome back to the workbench. Today what I'm doing is creating a replacement for this base that broke off of my little Insta furnace ceramic heater. What happened was it fell. It sat in there like this. So there's the assembled piece, what it would look like if it wasn't broken. And this goes on there like that. And this piece attaches to the bottom of the actual furnace heater itself on the bottom, and then it slides back and forth, so you can slide the heater, move it slightly like this. Now, I don't know if 3D printing a part's actually going to be a good solution for this. The centerpiece in here might not work out well when I use the bolt, or a little screw rather. There's the hardware for it, a couple of washers, a spring, and a screw. So the spring gives it some tension so it doesn't just wobble around, and the washers help hold it in place on the rounded bit, or spherical bit, and the screw just holds it all together. So it's a pretty simple assembly. But what I'm going to do is design a replacement for it, and I think it'll work. We'll see. Also, might not be the best idea if it was designed in something which the heater will overheat, so it might require some testing, and the whole thing might turn into a puddle of flaming goo, or at least goo, if I'm not careful, and if the heater generates too much heat to the chassis, which I don't think it does, but you may not want to do this yourself because it might not be safe. But for the purposes of creating a piece, it works as a pretty good example. Fabrication, that is. So here we go. And here we are. What I'm using here is OpenSCAD. It doesn't always work the best for some different types of designs, but for a simple measurement of all of the dimensions of the object and just an assumption on the sphere, because I didn't want to do too much work to figure out exactly what the size was on that, and it didn't look like it needed to be that exact. There's my design. It's pretty simple. If you can see up here, the cube. Let's see, we just set a few variables for the cube for the base, and then set the foot offsets here for our offsets on the feet. And then there's a cylinder fineness, essentially. It just makes sure that you get the correct number of corners to your circles, essentially. So they're finer or not as fine, depending on how well you want it to render out. There's only a certain amount of possible accuracy that you're going to get out of a 3D printer, so I don't bother setting it too high, but I do want it higher than the defaults. Otherwise, you'll end up with something like an octagon instead of a circle, which probably isn't what you want. And then we've got our cube. We've got the sphere cut out of it. Then we've got the 4 feet down here. Right there. There's the 4 feet. And then down here, what we've got is the center piece, which will hold the screw to hold it all together. Now, I'm not sure that that's actually going to work that well. It might not be sufficiently strong to actually hold the thing, but all it needs to do is support the bottom of the heater and not melt. Those are the most important things. I might need to do a second iteration if the sphere doesn't have a large enough diameter. That was just eyeballed. What I did is took the micrometers and then just checked by eye and kind of estimated what the total sphere size would be, and then typed it in as the total diameter. I think the sphere might actually be a little bit small, so we'll change that up a bit. And let's see what happens there. That's probably going to pop it through the bottom of the model with the way I designed it. It did. So we need to rotate this up slightly. Now, if you were designing this a little, oh, what on earth did I do there? Let's reset that. I may be forgetting something. Oh, yeah, there's an extra letter there. There's the problem. Okay. So we need to move this up on the translation. Translate moves the object around in space. So what I'm doing is I'm moving it up and down as I'm changing the numbers for the translation on the z-axis. The last axis, I believe, goes X, Y, Z, which is pretty easy to remember if you're used to 3D printing. Same as the axes of the printers generally on a Cartesian model. Fool around with this for a second and I should have it done. And then one of the other things I like to do is check it on the wireframe to see roughly how deep it's at. That looks like it's probably a little too deep on the plastic. Zooming in a bit. Yeah, that's going to be right kissing the bottom, so we probably want to move that a little bit further. Let's see how 40 looks. Oh, whoop, that's the other direction, so we need 44. Since we want to move it 2 millimeters. And there. That's probably a couple millimeters up from the bottom. Might want to go slightly higher than that. Let's see what 46 looks like. Might just end up cutting it in the center and going 45. That is probably a bit more than necessary. Let's just go 45. Well, let's go back to 44 actually. Since it's going to be completely surrounded, it should be fine. Let's see what that looks like. That actually looks pretty good. I think I might be happy with that design. Yeah, because on our original design. All right, hold on a second. Let me cut back to the camera, and then we'll see what the measurements were that I took initially to design it, in case you're curious. And here we are again. All right, so the designs I did was pretty simple. All I did was grab my, still kind of crap micrometers, Vernier calipers actually. Took the measurement of the, took the measurements of the plate, which were 133 roughly, 153. I took a measurement of these feet, which I determined were about 8 millimeter total diameter, radius about 4 millimeter. Checked the depth of the opening, which was about 13.5, so 13.5. Did the globe to see what the diameter of that was, and for that, all I did was estimate it, so I just lined it up quick. Figured about how far out the full globe would be. So there it is, we're currently at 60, and I figured that it was probably going to be about, if it were a full globe, probably about 80 millimeter on the sphere, somewhere around there. I think we just stepped it up to 100 just because I didn't like the look of the opening and I figure it can be a little bigger. And I can always iterate over a second version of the design if it doesn't come out right, so that should be fine. And I think that's it. Those are all the measurements I actually needed to design that in OpenSCAD, so it was pretty simple. I don't use OpenSCAD for everything. It's not often the right tool for the job because if I need to design something visually instead of designing it mathematically with some measurements, it doesn't always come in handy. And sometimes it's easier for me to design things visually, whereas somebody else might be able to design it better mathematically. If there's an OpenSCAD library for something, such as threading, sometimes it is easier to use because someone else has already done the hard math involved with putting in all the measurements for the threads and figuring out the cylinders and figuring out what the difference is going to be, and what all the equations work out to. So in OpenSCAD, sometimes it is easier to use because someone else has done the hard work on gears and math for threads and what have you. And at that point, you just need to pop it in. You can use their equation that they've created for you and put it into the software. And over time, you can probably learn how to use it effectively if that's something you want to do. It does take a bit of learning, but it's the same learning you'd be doing if you're learning how to engineer something that way anyway. So you do kind of have to know how to make something by hand in order to learn how to make it in a CAD package of any sort. Otherwise, you're not going to be very effective at doing it, I would think. Depending on what you're doing, of course, there's exceptions to that. I always find it easier to understand how to do something prior to attempting to model it with something, or to cheat, essentially, and use a simpler method to do it. Once you understand the meaning of what you're doing, it's easier to go back and then learn a simpler way of doing it, and learn a automated method. So that's just my methodology for doing it, though. All right, let's check some slicer settings, see what we've got on there, and we'll cut a copy of that piece and then see how it fits. Might need a couple of iterations on it. I'm thinking my OpenSCAD package might need to be updated a little bit. And here we are in Slicer Prusa Edition. What I'm going to do is just add the model to it. Let's see, electric heater base. We'll switch back to the 3D view. There we are. This is the MMU2 version, so you have this big block over in the corner. It'll automatically get rid of that if it's not necessary, so if we're only using a single extruder. I've already switched to extruder 3, so we're all set there. The infill is gyroid, and I've changed the fill density down to 15% because I'm just going to do a quick iteration on this, and 15% might actually be okay with gyroid infill. The gyroid infill is pretty durable, it holds up well, so it probably won't take nearly as much infill with that. The downside to it is it takes a good bit longer to print, I think. I'm not positive, I haven't timed it, but it seemed like it took a long time. Quite a bit of extra time on the print when I was going through it before. And the rest of the settings are pretty much standard, I believe. I don't think I've changed anything else. I am using the Prusa PET MMU2 setting for Amazon red filament on that roll, I believe. We'll see how well that turns out. And it shouldn't require any support, as it's all printing from the bottom. There's no overhangs anywhere on this design. I just flattened the bottom. I could have done it like the original, where there was a chamfer with the sides going up, but it doesn't matter that much, and I don't think it would really add anything to it. All right, let's slice that. And there, you'll notice the purge block has gone away now because it doesn't need it. There's our design. It looks good. Scroll down. There's the gyroid infill. Zoom in on that a little bit. Gyroid's kind of neat. It prints in these wavy patterns that are all interconnected, and they go horizontal then vertical. So it, in theory, I think, provides much better support while also not using any more plastic than, say, a standard infill crosshatch. Although I don't know that for sure either. I didn't actually check that, but I'm assuming it doesn't use much more plastic for the amount of rigidity you get out of it anyway, even if it does have a slight difference. All right, let's get this over to the printer and print out a prototype and see how she comes out. And here's our finished product. I actually screwed up two things on the first design on this. These holes were supposed to be on the bottom, so I'll have to drill straight through and just insert them from the bottom. I don't think that'll cause a structural problem with this, really. We'll see. Might have to reprint it if it does. Also, I forgot to actually put a hole on here somewhere for these to come through the screws, so I can't actually tighten them up from below. But what I'm going to do right now is mark the plastic in one spot. Let's see if that worked. Yeah, it's marked. You can probably not see it on the camera, but right there, I marked it. What I'll do is I'll just drill through right there, one spot, and then rotate this around with the heater on top of it and tighten up each screw in turn. I should only need the one hole to tighten all three of them. And then it'll be all set. Yeah, it actually worked out really well. The sphere is perfectly sized. The opening works out well. The pillar to hold in the screw actually is set perfectly. It fits nicely in there. So I think it's a success overall, even though the problems with the side of the mounts for the feet and with no screw hole in it for the screw tightening. I'm still pretty happy with the design. I'll put up the actual files for OpenSCAD on the website and make those available. And along with the STL of the fixed design, and the OpenSCAD files will be fixed obviously for it. And now that all drilled out again, time to reassemble the thing. So, there we go. Practical application of designing something for 3D printing. In this case, a household item and replacement for an unreplaceable part, which you can use the same methodology though to design an industrial piece or whatever you happen to be working on. This one used OpenSCAD, because I think that might have been the easiest tool for me to design it with anyway. And a slicer, slice it up, the i3 Mark III to print it, and then a little bit of machining on the bench drill so that I could retool some of the bits that I screwed up on in the original design that I could go back and rework, but I don't really want to spend any more time on it, and I don't think it's really worth printing again with the faults that are in there. Seeing as how the sphere was correct to seat the half-round swivel part in, that's actually all I was really concerned with, that and the post that the screw goes into to hold it on. And that all seems to be fairly secure. Yeah, so I'm happy with the results. Thanks for watching. You can subscribe below if you like the video. You can leave me comments or any kind of questions you might have in the comments section or on PCburn.com. And again, thanks for watching. See you next time.